Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 5.4, which is going to deal with side-side-side triangle congruence. Now, before we jump into today's lesson, I just want to make you aware that section 5.4 is the final section of Module 5, and just like every last section of modules, expect a quiz upcoming soon. So just something to be aware of, and just something I wanted to let you know. Alright, for today's lesson we have one learning goal, and our learning goal is that you will be able to prove two triangles congruent using the side-side-side, or SSS, theorem. So today we're going to take a look at our third triangle congruence shortcut. So far, we have talked about angle, side, angle. We've also talked about side, angle, side. Today, we are going to take a look at our third one, which is side-side-side, or SSS. So, side-side-side is going to imply this idea that if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. What that means is today, when we go through and state whether or not triangles are congruent, if I can say that all three sides match all three sides in the other triangle in terms of size, then I can say the two triangles are congruent based off side-side-side. So today, we're not going to really worry anything about angles. We're just going to look at side lengths. Now, to draw a representation of what a side-side-side triangle congruence would look like, you would have all three sets of sides that have a matching corresponding pair. So it would look like this, where I could say all three sides have a corresponding matching pair in the other triangle. So if we were to notate this, we would then have three S's all the way around the triangle. So today's stuff, look at side lengths. Alright, so that is what side-side-side is. Let's go ahead and jump into our first example for today, which is going to ask us, like our other examples from the previous sections, to determine if these two triangles are congruent based off side-side-side. So if we look at example 1, part A, we have triangle ABC and triangle DEF. We have to determine if these two triangles are congruent. And again, today we're going to look at it based off side-side-side. So if we look at our first triangle, so ABC, if I start with the side AB, the side AB is 1.7 meters. So what I have to do is find a side length that matches that in this triangle. And I see that I have one right here with DE, that it is also 1.7. So I know that AB is equal or congruent to DE because they're both 1.7. So AB is congruent to DE, and that's my starting point there. Then we just have to go through and identify the other two sides. So if I start with BC is 2.4, in this triangle EF is also 2.4. So these two sides are congruent. So we have BC is congruent to EF. And then lastly, AC is 2.3, and then DF is also 2.3. So that means this third side is also congruent. So I can say AC is congruent to DF. So, can I determine that these two triangles are congruent? I can, because I know all three sides are congruent to each other. They have that corresponding matching pair. So I can say yes, and it's going to be by side-side-side. Okay, so that is how we're going to run through example 1 today for parts B, C, and D as well. We're just going to go through and determine if we can say all three sides have a corresponding pair. If they are, we can say the triangles are congruent. If we cannot, then the triangles are not congruent, and then our answer is just no. All right, if we take a look at B, so for part B, we have triangle PMN and then SRQ. We have to determine if these two are congruent to each other. So first, if I start with the side PM here, it's 54 inches. Do I have a 54 inches over here? Okay, I do. So I know that PM is congruent to SQ. Next, if I go to PN, so that's 38, and then my 38 over here is SR. So I know that PN and SR are congruent to each other because they are both 38 inches. So we can say PN is congruent to SR. And now I have my second set of sides. So all we have to do now is just confirm if our third set of sides are congruent. So for MN, it is 28, and then RQ is 32. So because MN is 28 and RQ is 32, those are not equal to each other, therefore they are not congruent. So my two triangles are not congruent. And my reasoning for that is because MN is not congruent to RQ because 28 does not equal 32. So while I do know that two side lengths are congruent to each other, I do know for a fact that the third set of sides is not congruent. Therefore, I can say that these two triangles are not congruent to each other. So if there's ever one set of sides that does not have a matching part, then you just need to instantly go ahead and say that they are not congruent, and that's your answer. If you can find all three sets of sides to be congruent, then your answer is yes. So that's the gist of what you're doing today. I do want to run through parts C and D just to kind of give us more exposure to it and to see stuff, and then we'll move on to examples 2 and 3. All right, so parts C and D are just like what we talked about with parts A and B, where we are going to go through and determine if the triangles are congruent. So if we look at C, we have triangle DEH and GHF. So we have to determine if these two are congruent, and we're specifically going to continue using side, side, side. So, first up, if we start with DE, so DE here is 20, and I know that GF over here is also 20. So I can say that DE is congruent to GF because they are both 20 centimeters. So I can say DE is congruent to FG. All right, next, let's go with DH here is 12, and I know over here that HF is also 12. So because these two are both 12 centimeters, I can say that DH is congruent to FH. So I already have two sides, we just have to confirm our last side is congruent. So if we look at EH, it is 24, and GH is also 24. So I know that this side is congruent to that one. So I can say EH is congruent to GH. So I've successfully said that all three sides have a matching corresponding pair in the other triangle. Therefore, I can say that these two triangles are congruent by side, side, side. Now, for this one in particular, okay, we can say it's congruent by side, 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 but just one thing to note, because I want to keep it fresh in your mind. Okay, two straight lines that cross, vertical angles or opposite angles are congruent. So these two angles are congruent to each other as well. So I could also say, based off side, angle, side, that these two triangles are congruent. Now, right now we're just worried about side, 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 but know that they all do intermix and come together. So don't ignore or forget the side, or angle, side, angle, just because we're talking about side, side, side today. There's multiple and numerous ways you can prove triangles congruent. We're just going through step by step, talking about more and more. Okay, the last one for part D, we have our diagram like such. So we have KGJ and LGJ. That's fun. So we have these two triangles, and we have to state whether or not they are congruent to each other. So if we start out with, let's go with the fact KJ has one congruent tick mark, and I also see that on my other triangle that JL has a one congruent tick mark. So because these have one tick mark, that means that these two are congruent to each other. So I know that KJ is congruent to LJ. So that's my start. Next, they tell me that KG, because it has two tick marks, is congruent to LG, because this also has two tick marks. So I can say KG is congruent to LG. So I have my second set of sides. And then lastly, if we look at this side right here, JG is congruent to itself. So I know this side is congruent to this side. So this side right here, JG is congruent to itself. Based off the reflexive property, they share that side. It's the same side. So I can say that that side is congruent to itself, thus giving me my third and final side. So now that I have said that all three sides are congruent to their corresponding pair in the other triangle, I can say that yes, they are congruent by side, side, side. And that is example 1. So, if you are asked to determine whether triangles are congruent, your main goal today is to identify based off side, side, side. Now, if questions about side, or angle, side, angle pop up, okay, don't drop those. Keep those in mind as you run through your problems. Okay, they build up and we keep adding on. In fact, we still have 2 more to go after this lesson. But today is really just focusing on side, side, side. All right, that is example 1 on determining if triangles are congruent. Now, example 2 is going to follow the same format from 5.2 and 5.3, where it's going to request what additional information do we need to know to state that these triangles are congruent to each other. So just like we did in 5.2 and 5.3, we either have to identify an additional side length or an additional angle measure to say these are congruent. Now, for example 2, they want us to go based off side, side, side. So I need to say that all 3 sides are congruent. So we just have to identify what additional side length we need to know to be able to say these are congruent. So if we look at A, for part A, they tell me that ST is congruent to TI based off my two congruent marks. So I already have one side because they told me. And then I also know that TR is congruent to itself based off the reflexive property. So I know TR is congruent to TR using the reflexive property. So I have two side lengths that I know, one based off them telling me, and two based off of using the reflexive property. So what is the additional bit of information I need to know? What's the third side lengths I need to know are congruent to each other? Well, I need to know that SR is congruent to IR. So my answer for this is SR needs to be congruent to IR. And that is my answer for example 2. So I just need to know that third side is congruent to the other third side, and that's all you have to do for that. Alright, part B is really just carrying the same idea. So they tell me that VN is congruent to ML based off that tick mark that they tell us. So I know I already have a side length and a side length. I know that NL is congruent to NL based off the reflexive property. So I know that side length is congruent. So the last bit of info I need to know is that this side is congruent to this side. And that will have successfully accomplished the side, side, side. So I can say that VL is congruent to MN. And that is my answer for example 2, part B. Alright, so that is it for example 2 in identifying additional information you need to prove the triangle is congruent based off side, side, side. Alright, so one more example to go, and example 3 is going to have us use the properties of side, side, side to answer our question for each one. So example 3 asks us to find the value of x and y that is going to make the triangles congruent. So today we have done everything based off side, side, side. So I need to know that all three sides are congruent. So that means I need to be able to find the value of x or the value of y that makes that the case. So I'm going to pull up my calculator because there is a little bit of solving today for each of these problems. So for example 3a, they give me the two triangles ABC and JKL. We need to go through and determine what the value of x in this 4x minus 6 and the value of x in this 3x minus 4 is that makes these congruent. So first of all, with the side AB, this is 3 centimeters. Okay, so AB is 3 centimeters. And I have a matching pair of JK in the other triangle. And then AC is also 3 centimeters. And I have another matching pair in JL. So I don't need to worry about those two parts because I've already identified them. So that means I'm going to take this 4x minus 6, and it needs to equal this 3x minus 4. So what we're going to do for this problem is take both of those expressions and set them equal to each other, and then solve for x. So first step is taking the 4x minus 6 and set it equal to 3x minus 4. Your first step is to get the variable on the same side. So I'm going to move this 3x over to the 4x. Because it's a positive 3x, I'm going to subtract it. So if I do 4 minus 3, I just end up with a 1 or just x. So we have x minus 6 equals negative 4. And then continuing to use our algebra skills, we just have to add this 6 to both sides. And if if we do negative 4 plus 6, we end up with 2. So for part A, we need x to equal 2 to be able to say that these two triangles are congruent. Now, if you want to plug it back in to double check to make sure 2 works, we're going to plug 2 into this 4x minus 6. So 4 times 2 minus 6. And we end up with 2. And then if we plug it into here, this 3x minus 4, we should get the same thing. And we end up with 2 again. So both of these would then end up equaling 2 centimeters, thus proving and thus showing that these two triangles do end up being congruent. So that is how we're going to go through and find the value of x or y today. We just have to go through and match the missing part. Okay, let's go on to B. So part B is going to be the same idea, just different situation. If we look at B, so I know that mn is 4, so I've got 4, and I have a 4 over here with RQ. MO is also 4, just like RP. So that means this third side of this 3x minus 11 needs to equal 4. So whatever my value for x is, when I plug it in, it needs to end up, when I plug x in, to equal 4. So what we're going to do for this is take this 3x minus 11, set it equal to 4, and then we're going to go through and solve. So we're going to add 11 to the 4 first. So 4 plus 11 is 15. So we get 3x equals 15. We're going to divide 3 over to the 15. And we end up getting x to equal 5. So now that I know x equals 5, excuse me, if I plug 5 back in here, if I do 3 times 5 minus 11, I end up with 4, just like I needed it to match over here. So I now have found the value of x that makes this 4, which then allows me to say that these two triangles are congruent based off side, 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 and thus completing my answer for part B. Okay, so that is parts A and B. Next, I want to take a look at part C, and I want to take a look at part C because it abandons the idea of side, 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 and in fact has us go to different congruent statement. In fact, it has us go to angle, side, angle. Okay, so if we look at C, it wanted us to go through and find values of x and y. And the reason I want to talk about this is just in case it pops up in the homework that you've seen it and you have an example to reference. So, first of all, okay, my value of x is this 8x minus 12 centimeters, and the only other side length that I know over here is 12. And if you notice, they look like they'd be the same part because it's not the hypotenuse, but it is the longer leg. So I'm going to take this 8x minus 12 and set it equal to 12 to figure out what x equals, or what x needs to equal. So we're going to take 8x minus 12, set it equal to 12, and then we're just going to go through and solve. So we're going to add the 12 to the right, so we get 8x equals 24. And then if I divide the 8 to the 24, we get x to equal 3. So I need x to equal 3 so that these two sides can be congruent to each other. And if we want to double check that, I'm going to plug 3 into this 8x minus 12. So we're going to do 8 times 3 minus 12. and I get 12, which is what this side equals. So we are good on that front. So next we need to figure out the value of y for this problem. So if we look at y is relating to this ty plus 7. Now, what angle does this match up with over here? Well, it is going to match up with the 60 degrees, the F, because it's the one that's a little bit bigger than the 30 degrees, which H is 30 degrees. And I know that H is 30 degrees because if I do 180 minus the right angle 90 degrees minus the fact that I know this is 60, okay, I end up getting this as 30. So that means, because this is 30 and this is 30, this is 90 and this is 90, that these two have to equal each other, because that's the missing pair, or that's the matching pair in both of the triangles. So I'm going to take this 7y plus 4 and set it equal to 60. Again, I'm not setting it equal to 30 because 30 is already taken by angle V, and the right angle is already taken by the right angle here. So the only part left open is the 60 degrees. Okay. So we're going to take 7y plus 4 equals 60. We're first going to subtract the 4. So we'll end up with 7y equals 56. And then we're going to divide 7 to the 56. And if we do 56 divided by 7, we end up with 8. So I need y to equal 8 in this case, and we're going to double check it by plugging 8 into this expression to see if we end up with 60. That would then give me my 30, 90, 60, and my 30, 90, 60, if that works out. So we have 7y plus 4, so we're going to plug 8 into that. So we're going to do 7 times 8 plus 4, and we end up with 60 degrees. So that gives me this to be 60 degrees. So I now have a 30, 30, 60, 60, 90, 90. And the fact that I know this side is 12, and I know this side is also 12, I can say based off angle, side, angle, that these two triangles are congruent. So that is how we run through example 3 with going through and finding the value of x that would make these two, or each situation having the two triangles be congruent. So with that said, that is it for our notes today on section 5.4 with dealing with side, 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 triangle congruence. Again, section 5.4 is the last section of module 5. Again, something to be aware of and just keep in mind. So that is it for today. Thank you guys for listening. If you have any questions, as always, just let me know the next time you see me or shoot me an email. Otherwise, that is it for today, and I hope you have a great day, and I'll talk to you guys later. All right, bye.